It's back. My first review of this printer was so bad they took it off the market. They just sent me the new version, so let's see if they fixed all the things. Welcome back to Cloud 42. I'm James. If you remember, about 3 months ago, I reviewed the QIDI X-Plus3 printer here on the channel. I did not have a good time, and my review was critical. In fact, it was bad enough that a couple of days after my video went live, they pulled the machine off the market so they could make the big changes that it really needed. And that brings us to today. I have the new version of the machine here. I've been testing it and it's pretty good. I'm not seeing any of the issues I had with the first version, and I think this machine's going into my fleet. I'll get into the details in a minute, but first some disclosures. QIDI Technology sent this printer to me along with a few rolls of filament free of charge in exchange for this review. They had no input into the content of the video. In fact, they didn't even get to see it until it went live on the internet for everyone. The links in the video description are affiliate links, so if you use those links to buy something, I earn a small percentage and the price is the same for you. Just keep that in mind as you evaluate what I have to say about it. I debated for a while about what to do with the original review video. I don't want to delete it because it's true and it happened, but it also doesn't accurately represent the printer that you'll get if you buy it today. And since it's currently the #1 result on YouTube when you search for this printer, that's not really fair to QIDI. So I decided to mark the video unlisted. It won't come up in search results, but it's still there, and there's a link down in the video description if you'd like to go watch it for historical context. This is the new version of the QIDI Tech X-Plus3. It's one of a new crop of fast Core XY printers that are all trying to chase down Bambu Lab and get a piece of that market. The quoted speed specs are 600 millimeters per second and over 20,000 millimeters per second squared acceleration, putting it on par with the fastest commercial offerings, though that's not super practical. More realistic printing speeds are around 200 millimeters per second, and those are primarily limited by the melt rate in the hot end and the ability to cool and freeze the material after it's extruded. The flexible magnetic build plate is 280 millimeters square, making it a little bit larger than the Bambu Lab machines. And it also has an actively heated chamber that goes up to 65 degrees, which allows it to print difficult filaments like ABS with less warping. It also has an additional cooling fan on the side of the chamber for fast freezing of filaments like PLA. The X-Plus3 is running Clipper with input shaping, and the fluid web interface is active for remote control and monitoring. It doesn't have a webcam, but you can add your own by plugging it into the external USB port and turning it on in the web UI. There's a copper alloy nozzle pre-installed, and it comes with a hardened steel nozzle that you can install to print abrasive materials up to 350 degrees Celsius. It has automatic bed leveling, but you do still have to set the Z offset manually. This isn't as convenient as the nozzle probing on the Bambu Lab machines, but it works. And once you have it set, it stays pretty consistent. There are quite a few changes in the new version of the printer. The plastic floor plate has been replaced with a welded steel stamping and an aluminum reinforcing bar, and the carbon fiber gantry rods are gone, replaced with hollow steel. The optical homing sensor at the bottom of the bed travel is gone, and there's a new inductive probe in the tool head. They've also switched some of the parts of the hot end assembly to titanium and upgraded the cooling fan to prevent the heat creep jams that we were seeing previously. If you had the first version of this printer, there's a fair chance you crashed the bed on first startup because you didn't notice the shipping blocks underneath. Those are gone now too. To test this new version of the printer, I pulled out the same models that I used last time, but unlike last time, everything just worked. In 24 hours, I had all of the prints done that I had struggled with for 6 weeks on the first version. Starting with the included roll of PLA, I printed the pre-sliced benchy that was already loaded on the machine. It printed in, I think, about 18 minutes, and it looks fine. I've seen cleaner, but not much. It's fine. One of the prints that really shows bed leveling problems is this Raspberry Pi Zero cover for the Prusa Mark III. If you have any issues with the first layer being too high or too low, this print will either fall off the bed or have sharp squished edges, and this has neither. It's good, and it just worked again on the first try. Switching to another roll of QIDI PLA that I had left over from my iFast testing, here's the infamous clock spring torture toaster. And once again, it printed great. The gears in the doors move freely. The overhangs look very clean up to about 70 degrees where they first start to show some sagging. I was able to get all of the clearance sliders to move except for the very last one at 0.1 millimeters. That's pretty respectable. And the toast moves freely without any stringing or other garbage hanging it up. I also printed the Maker's Muse puzzle cube, and it's fantastic. The surfaces are smooth, the fit is great. This thing has some pretty extreme overhangs due to the printing orientation, and I really can't see any issues with it at all. Since things were going so well, I printed one of the many lattice cube torture tests floating around the internet, and it looks pretty good. There's a tiny bit of wispy stringing in there, but it's pretty minimal, and a quick blast from a heat gun would take care of that. Back to the black PLA, here's the Clipper ringing tower, and it looks really good. I see some very faint artifacts in the large flat areas, but I discovered later that one of my belts was loose. I tightened it up and ran it again, albeit with a different filament, and now I'm not seeing anything. This is clean. Switching over to ABS and firing up the heated chamber, I printed a batch of electronic lead screw spacers. This is the same job I have been running on the Bamboo, and it worked fine. I could probably nitpick some of the fine details, but these are solid functional prints. Here's one more ABS print. This is my 2-liter coolant bottle hanger. This is also nice and clean and solid. But all of this stuff is pretty pedestrian. Let's try something harder. This is the body for a 30-pound combat robot called Drain Bamage, designed by my friend Robert Cowan. This is just a prototype, of course. The real thing is milled out of S7 tool steel, and it is a thing to behold. I'll put a link to his video about it down in the description. This thing is big, it's flat, and it has significant vertical walls around the edges, making it perfect for warp testing. It also has huge areas where the printer is running at maximum speed for an extended period of time, making it perfect for extruder flow testing. So can this printer manage a worst case print like this in ABS without warping? Yes, sort of. Here's my first attempt. This is eSun ABS with the default settings, including the heated chamber. I stopped the print when it got to this point because I noticed a rough area here on the top surface. The printer is under extruding a little in this area due to the huge flow demands. The printer is running at maximum speed and trying to flow almost 20 cubic millimeters per second, and it just can't quite keep up. But it is pretty flat. I raised the temperature and tried again and let it finish this time. The good news is that the part stayed really flat. That's truly impressive for a print with this geometry in ABS. The flow rate was a little bit better, but it's still not perfect. I slowed it down to around 12 cubic millimeters per second, and that fixed most of the issues with the top layer, but the extra time and probably the better layer bonding led to more warping. This is still way better than you're likely to achieve without a heated chamber, but the heated chamber is not a panacea. It's worth noting though that I put almost a kilo of ABS through this thing at elevated temperatures with the heated chamber and had 0 issues with heat creep. So the upgraded cooling system seems to be working. QIDI sent me some samples of their other engineering filaments, so I ran the same test with them. First up is ABS GF25. This is ABS with 25% glass fiber fill. I ran the same Drain Bamage shell test with the default settings, and it looks really good. It stayed ruler flat and it feels very rigid. The surface is a little bit coarse, which is what I would expect from glass fiber, but this is really respectable. Next up is PET CF. This stuff prints really hot. I think the default profile runs at 320, and they advertise it as having good heat, chemical, and creep resistance. And it printed great. I think the quality of the top surface is a little bit compromised because the bridging sags a little into the infill. I'd probably add another top layer or two to clean that up. And last is one of my perennial favorites, the PA12 carbon fiber. I love this stuff in the XCF Pro because it's just so smooth and predictable, and it works just as well in this printer. This part has some of the best top layers and the best looking surfaces of any of the materials I've tested in this printer, except maybe PLA. One of the challenges that can come with high-speed 3D printing is a reduction in the strength of the finished parts. I wanted to do a little bit of testing, but I really didn't want to do a lot of work, so I just printed out some of these and we're going to break them and I will share my thoughts. This is a carriage lock for the Avid CNC router. I designed this so this can be bolted on to immobilize the carriage for lifting. Of course, the finished part is 1/4-inch steel plate, laser cut and bent. This was just a prototype for testing the fit. Now, this is not a scientific test. I know it's not a scientific test. You know it's not a scientific test, but if you really just cannot help yourself, go ahead and tell me down in the comments that this is not a scientific test. I'm just going to break these and tell you what the experience was like. So these are printed with the filament orientation running around the part for maximum strength. It was printed standing up on the bed with support material underneath here. This first one is printed in PLA. This is the sample roll of PLA that came with the printer, and this was printed with the copper alloy nozzle. So this is, I think, 3 walls, and I'll just pull on it. Okay, that's actually quite a bit stronger than I expected. Wow. That's pretty good. As far as PLA prints go, with a 3-wall print, that is right up there with the strongest I've experienced. You're gonna have to forgive me. There are airplanes just circling my house today, and since I can only break the parts once, I can't do a second take and edit it. The second print is also PLA, but this one was printed with the hardened steel nozzle. This is printed with the copper alloy nozzle that was intended for PLA. This was printed with the hardened steel nozzle. I just wanted to see if there was any difference. And yeah, there's there's a massive difference. Look at that. Yeah. Okay. I had heard a rumor that the hardened steel nozzle was not good for PLA, and I wanted to try it out, and sure enough, look at that. I don't recommend the hardened steel nozzle for PLA. I did try one other thing, and this is printed at 240 degrees, again with the steel nozzle. This stuff normally prints at 220 with the copper. It obviously isn't working with the steel. I tried raising the temperature to 240 to see if that would help. And yeah, actually, that's pretty good. That's pretty similar, so maybe you can run it. I mean, obviously the copper works really nice and smooth. This is what they did all their testing with. But it looks like if you raise the temperature, maybe you can use the steel nozzle. Another airplane. I'll just wait for it. This one is the ABS GF25, so this is a 25% glass fiber reinforced ABS, again printed with the default settings, but 3 walls in the heated chamber. And my first impression of that is that it's very, very rigid, maybe even a little bit more rigid than the PLA. And it actually is pretty strong. I think the braking resistance on this was a little bit less than the PLA. So that's the glass fiber reinforced ABS. This one is the PET carbon fiber. So the carbon fiber reinforced PET, this is the stuff that was printed at 320. And that's quite a bit stronger than the ABS glass fiber and the PLA. Wow, okay, I can break it, but Okay. Okay, I can break that. Keep in mind, I deadlift 465 pounds, so my grip strength is significant, and I could just barely snap that. That's pretty good stuff. That's, again, the PET CF. And let's try the PA12 carbon fiber. That's stouter than I expected. Okay, so that is probably pretty similar in overall strength to the PET CF, but it doesn't fracture catastrophically. It gives more. This is nylon. Yeah, so I can crack it and it's separated there, but it's not just snapping and breaking in half. The nylon is much, much more resilient. That is way better than I was expecting. I was expecting this stuff to just snap, especially when it was printed fast, but no, that's really stout. Huh. I like that. That's a pretty good combo. All of the QIDI printers I've used previously, including the first version of the X-Plus3, used the QIDI print slicer, which was derived from Cura. But starting with this printer and its siblings, they have a brand new slicer based on, wait for it, Prusa slicer. I know, it's what all the cool kids are doing. In my testing, it worked great, which it should because it's Prusa slicer. They did reskin it with their own goofy blue icons, which takes a while to figure out what all the buttons do. But if you don't like that, they also provide profiles that you can just load into Prusa slicer. This is particularly nice if you also have Prusa machines and want to run the same slicer for everything. Now that I'm standing here thinking about it, I wonder if the profiles could also be loaded into Orca slicer. That would unify QIDI, Prusa, Bamboo, and a bunch of other brands. Let me know down in the comments if you've tried it. The modified slicer, as well as the Clipper software and configuration files and the printer firmware, all appear to be open source. The code is in a public GitHub repository, and after a few minutes of poking around, I was able to find the handler code for the touchscreen UI, so it seems pretty complete. The printer has both Wi-Fi and wired Ethernet. You can send jobs to it directly from the slicer over the network, and you can monitor progress and control the printer through the Clipper web UI. There doesn't appear to be any cloud functionality except maybe checking for updates. The printer does have 3 ports open on the local network: the Fluid Web UI port, a Moonraker server port, and SSH on port 22. SSH allows root login, and the default password is actually published in the GitHub repository. That's not awesome. Maybe in a home network it's not that big of a deal since you probably have softer targets on your network already, but in a corporate environment, this would not pass any kind of compliance audit. If you have anyone nefarious in your network, and you should assume that you eventually will, this is an immediate target for lateral movement and an additional foothold in the network. QIDI, we need a way to change the password, and better yet, the SSH port should be switched off by default and only enabled when it's needed. I didn't really have much trouble with the printer during testing, but I did run into a few issues that are worth mentioning. During one of my first long test prints in ABS, the printer stopped with this error message. I sent the logs to support and they confirmed what I suspected. The printer shut itself down as a safety measure because it was trying to heat the chamber and the temperature wasn't rising. This is called thermal runaway protection, and you definitely want your printer to do this. In my case, it looks like the chamber heater fan wasn't running properly at slow speed, so they sent me a firmware update that switched the control mode to watermark, or what we used to call bang bang control, where it just cycles between 100% on and 0% off, and that solved the issue. It might have been a weak fan. They did send me a replacement, but I never put it in. The firmware fix solved it for me. I had one other print that stopped with this communication error. Support suspected that it might be a bad USB cable for the tool head, and they sent me a replacement, but I also never got around to installing it either, and I've got many hours and many kilos of filament on this printer since without any more issues. The only other print problem I ran into was when running PET CF using the included dry box. It got partway into the print and just stopped extruding. At first I thought it was my old nemesis heat creep, but it turned out to be something much, much simpler. There are clips molded into the inside of the dry box lid, I suppose to hold a hygrometer, and the spool was just getting hung up on them. The extruder tried valiantly to pull the filament, but it just cinched down around the spool and stripped. I cut the clips out with a pair of wire cutters, and that solved the problem. My older QIDI dry boxes have the clips, but don't have this issue, so I think this is due to a recent mold change, and I expect they'll get it sorted. Or you could just solve it the way I did by cutting out the tabs. I did notice that the coating appears to be wearing on the build plate. It looks like there's a gold-colored pebbled surface with some kind of black coating over the top, and it's the black coating that's coming off. The build surface is a new formulation, and the adhesion is fantastic, maybe even a little too fantastic with ABS, but it does seem to be wearing. It's still working fine, so it might not be an issue at all, and it might be something that they're still sorting out with the pre-production plates. So what's my conclusion? They fixed it. This is a respectable, fast 3D printer. How does it compare with the Bambu Lab X1 Carbon? I would say that it's not as polished as the Bambu Lab printers. You still have to manually set the Z offset. It doesn't have multi-material capability, and it doesn't currently come with a webcam. However, it has a larger build area and a heated chamber, and it's less expensive. So if you need to print larger objects and you want to print materials that need a heated chamber, this might be a good choice. And of course, the open source firmware and the fact that it isn't cloud connected are going to be attractive for some people. For me, this printer is going into my fleet for two reasons: the larger build area and the heated chamber. It'll be replacing the XCF Pro, which I've really enjoyed, but this printer will do everything that it will do in about a third of the time. If you enjoyed this video or found it useful, give it a thumbs up, subscribe, and maybe consider supporting the channel over on Patreon. If you're already a patron, thank you. You make it possible for me to do this. Thank you for watching.